Okay, Assalamualaikum warahmatullahi wabarakatuh. This is chapter 10, our last chapter for CIC 2 part 3. Okay, chapter 10, the internet. All right. So, this is what we are going to cover in our topic. Okay, the internet history. Second is internet working, multimedia on the web, and also mobile multimedia. Okay. So, actually, the internet itself began as a research network, okay, and also it started for the defense military, okay, for the military, U.S. military. So in 1989, the National Science Foundation took over the management of the ARPANET. So remember, the first when we start this internet, it's actually for the military purpose, okay, and then before 1992, the internet was not permitted for the commercial and business use. Okay, and after that, after 1992, then the internet is permitted to the commercial and business use, but the business have since become driving force actually. Okay, because of the business purpose. Okay, so I think even the first email maybe around 1990 to 1993. Okay, we start using email, right? Okay. So this is the word statistic for the internet usage. So in 2017, okay, even now 2019, I think the latest statistic 2021, um, the Asian, okay, the Asian country, actually is the biggest or largest world internet usage. Okay, like I think Malaysia is one of the most uh, one of the state with the most internet user. Okay, so if you look at this statistic, okay, from Asia, 48.7%. Okay, the largest internet users among other regions. So okay. So look at this network. So basically in a network, the server computer provides network services to the client computer on that network. So you must attach to that network. Okay. For example, we have this campus area network. So in a campus, we have this campus area network. So a few buildings that's connected in one or in the same computer network. Okay, so by using internet, several local area networks, or we call it as LANs, can be interconnected using gateway and routers to form a wide area network. One, so we know that one is formed from few or several LANs. Okay, so LANs and WANs can be connected to the internet through a server that provides internet software and physical data connection. So maybe among us we use LAN. Okay, so to connect several LANs, then we have the one network, okay, wide area network. This is the internet addresses. So in the internet address, we start with HTTP, right? So HTTP // is what we call as protocol, okay? And then www, World Wide Web, is the service. UITM is the domain name. So usually we have a specific domain name, okay? EDU or edu is a top level domain. We recognize that organization, okay, what kind of organization is actually based on, we can actually recognize based on this top level domain, TLD. Okay, and my, okay, at the end of the internet address is referred to country code. Not all using the country code, but we can have that country code. So if we can name a few, maybe JP, okay, Japan. What else? SG, Singapore. CN, China, for example. Okay, to name a few. So remember, internet address is consists of protocol, service, domain name, TLD, top level domain, and also country code, if any. Okay. So the DNS or the domain naming system assign names and address to computers linked to the internet. So each of the computer actually has its own domain, okay, or the DNS. So for example, this www.uitm.edu.my actually is a server. Okay, so that computer can act as a server, right? TLD or top level domains were established as category to accommodate internet users. So we know that the internet users comes from a different background, okay, a different organization. So when we're talking about com.com, it is for commercial entities, okay? .edu for the education, okay, education background, for universities, for schools, okay? And then .gov for the government agencies. Okay, MIL for the military. So what else do we have? For example, ORG. Okay, ORG actually for usually used for non-beneficial organization. Okay, so this TLD, as what we said before, is actually we can recognize that the category of that organization based on the TLD. Okay, so like www.uitm.edu.my. So we know that UITM is for the education, from the education background at UITM universities. Okay, top level domain. Okay, the two-letter US domain is based on the political background and political boundaries. Okay, so the IP address or the internet address is made up of 4 numbers separated by period. For example, okay, the IP address 192.168.1.1. Okay, so each of the computer, your own computer, for example, we have a unique IP address. So that's why if somebody, okay, they hack or they do something wrong on the internet, um, the cybersecurity actually can find who's the owner of that post or who's the owner of that particular anything happen, anything bad happen, okay, they know the source. Okay, why? They can detect the IP address, they can actually find the computer, who's the owner of that computer. Okay, so for your IP address, you can check through TCP/IP properties, right? TCP/IP. So what is TCP/IP? The Transmission Control Protocol (TCP) and the Internet Protocol (IP) are the protocols for communication on the internet. Okay, we used it. So how does this TCP/IP work? So basically, when you want to transfer a data, okay, a stream of data that is sent over the internet is first broken down into packets by the TCP. Okay, so for example, you have a block of data, it will be first broken down into packets. Okay, kind of for example, if we say that okay, I cannot use the pointer, but it's okay. Okay, it's okay. So the data packets actually, what does the data packet include? Okay, the data packet includes the receiving computer address or the destination address. Okay, a sequence number of the data of the packet. Okay, sequence number of the packet, and then the error correction information if you have to fix anything, to just to make sure that the data that arrived at the destination part is actually the same as requested by the requester or the client, and a small piece of data. All right, so hold on if I can. Okay, sorry. Oh, I don't have. pen, but it's okay. So, and then the IP, okay, the IP is responsible. I'm sorry. So the IP is responsible for sending the packet to its destination along a route. So how does the TCP IP works? First, the TCP will break down the data, okay, the data into packet, okay, and each packet will contain the destination address, the sequence number of the packet, the error correction information, and also a small piece of data. Okay, meaning that for a stream of data, for a data, when it being break down into packets, it will be numbered 1, 2, 3, 4, so that when it be combined together, they know which comes first. Okay, and then the IP is responsible to send the packet into to its destination. Okay, along a route. So that's how TCP IP works, to transfer or to transmit the data from source to destination. Okay. All right. So this is how it works. Okay. The first step, the TCP protocol breaks data into packets at the sender. Okay. And then step 2, the packets travel from router to router over the internet according to the IP protocol. So here we already know, okay, where is the destination, okay, because each packet has the destination address, okay. And step 3, the TCP protocol reassemble at the recipient or at the destination part. The TCP protocol reassemble the packet into the original whole. So remember, they have the error correction mechanism, okay, error correction information, just to make sure that at the recipient side, they will get the original data as been sent by the sender. Okay. So this is connection. So a telephone dial-up account and modem, a cable modem or a digital subscriber line, DSL, is required for network connection through an internet service provider. So what is the internet service provider? Okay, so in Malaysia, we have, for example, main, okay, the main one is TM, okay, and then we have Maxis, Celcom, Digi, Unify, what else? For example, our Tigrum in Mecca, for example, in Saudi Arabia, they have Zain, they have Mobileye, okay, so Mobily, okay. So these are the internet service provider available in maybe different, of course different for different country, okay. So this is the example of ISP in Malaysia. Okay. So the amount of data expressed in terms of bit per second, okay, BPS, okay, is referred to as a bandwidth. So bandwidth refer to the amount of data being transferred, okay. So bit per second. So the greater the bandwidth, the lesser will be the time taken to upload or download data. Okay, so bandwidth, if we have the analogy of bandwidth, for example, you have 5 cars, okay, 5 cars from destination A to B. If you have one lane, okay, one lane, so each car they need to queue, right? Need to queue. So one lane, because it has one lane only. So 5 cars, one lane. So if you have a larger bandwidth, okay, for example, you have 5 lanes. So each of this car, if they use each of the lane, okay, it will lessen or decrease the time taken to reach to the destination. That's the analogy of bandwidth. So that's why they said that the greater the bandwidth, the lesser will be the time taken to upload or download the data. Okay. So imagine that the cars is the data as data. Okay. So low bandwidth modem connection are a bottleneck for sending multimedia across the internet. Why we said that? Because, for example, at Senawang, okay, or Seremban Highway, for example, okay, from 4 lanes or from 5 lanes, just suddenly it becomes 2 lanes, for example. So from 5 to 2, that would be the bottleneck, okay? That would be the bottleneck. So same goes to the bandwidth, okay? So low bandwidth modem connection are a bottleneck for sending multimedia across the internet. Because we know that to send the multimedia, especially multimedia files, we need a greater bandwidth, okay? So you can see here, this is the ISP bandwidth bottleneck, okay? Okay, for example, our Wi-Fi network is 300 meg bps per sub, okay? We have a larger bandwidth, for example. But then for the ISP bandwidth bottleneck is only 1 meg bps. So just imagine from 300 to 1, so that's what we call as bottleneck, okay? So how to avoid this? How to solve the problem of bandwidth bottleneck? Okay, so bandwidth bottleneck can be avoided using the following option. The first one, of course, we have compress data before transmitting, just to make sure that we have a smaller size of data. Okay, so compress data before transmitting. Number 2, oblige users to download data only once. Okay, force them, okay, and then store that data on the system hard disk. So maybe the system will ask you, this file is already been downloaded. So do you want to download again, for example? Okay, that's how the mechanism works. Okay, oblige users to download data only once. Design multimedia elements to be efficiently compact. So when we are talking about compact, of course, file size is, we will decrease the file size. Okay, a smaller file size. Design alternate low bandwidth and high bandwidth navigation paths to accommodate all users, because we know that not all users need high bandwidth and not all users use or need low bandwidth. Maybe we have a different size of data. That's why if design alternate low bandwidth and high bandwidth navigation path, we actually can avoid the bandwidth bottleneck. Okay, so these are 4 options on how to solve or how to avoid bandwidth bottleneck. Okay. Okay, next, implement incremental streaming method. All right. So each internet service is implemented on an internet server by dedicated software known as daemon. So basically, daemon, also known as server, these are actually the process that run continuously in the background, okay, to perform function required by other process. So basically, these daemon, okay, are agent programs that run in the background, okay, and wait to act on request by other process. So this daemon is actually not under control by the user. Okay, remember that. And these daemons running in the background and running the invisible work. Okay, we cannot see it, but we know that it has it's been there, because we know that the background we can have the application in the background, other application can be run. Okay. So the internet support service such as hypertext transfer protocol, HTTP, and the post office protocol POP. Okay, so HTTPS. Okay, what is the difference between HTTP and HTTPS? Is actually, this HTTPS is actually a normal HTTP with encryption. Okay, with encryption. So sorry. The other services provided by the internet include HTTPS, FTP, Gopher, Usenet, Telnet, and so on. Okay, so each of these services actually have a different purpose. Okay, for example, if we are talking about Telnet, okay, to log on and working from remote computers. Okay, FTP. So transfer file between computers. Okay, so FTP, we can direct transfer file from computer to computer. Okay, and then IRC, for example, Internet Relay Chat. Okay, for real-time text messaging. So each of these service has a different purpose. So you should know, for example, SMTP, Simple Mail Transport Protocol, okay, for sending mail, right? So if you are talking about HTTP, HTTPS, so we can say that HTTPS is more secure, okay, it's more secure in terms of security part. All right, so multimedia in the web. So it is a new technique again to attract user to view web, okay, by using animation, video, audio, okay, to supplement traditional items such as text and graphics. So before this, we only have text and graphic. And then when we apply the implementation of element of multimedia, such as animation, video, and audio, it's actually to attract the user, okay, to view the web, okay. So WWW or World Wide Web, okay, was designed by Tim Berners-Lee, and it is a HTML is a hypertext markup language. So it is a protocol to link multiple documents located on computers anywhere within the internet. Okay, this WWW. Okay, and the hypertext transfer protocol HTTP provides rules for a simple transaction between two computers on the internet. Okay, remember, because when we are talking about data transmission, okay, or document transmission, document transfer, of course, between two computers. Okay, and then HTML is a document format for presenting structured text mixed with inline image. So HTML is actually a standard markup language to create web page. Okay, it describes the structure of the web page. So we use HTML. Okay, and then dynamic web page. So what does it mean by dynamic web page? So dynamic web page is actually a web page that display different content. Okay, each time it's viewed. For example, okay, if you view Google, okay, for example, Google, okay, for example, Google. So Google is one of the example of dynamic web page. Okay, so the page actually may change with the time of day or the type of user interaction. Okay, so example of dynamic web page is Google, for example. Okay, so there are two types of dynamic web page. It's either client-side scripting or server-side scripting. So for client-side scripting, they use a JavaScript, Flash. Okay, for server-side scripting, they can use ColdFusion, Perl, for example. Okay, so that is for dynamic web page. For XML, the extensible markup language is used to format and deliver web page using styles. Okay, web browser. So what is web browser? Okay, or we call it as search engine, for example. So this is actually an application that run on a user personal computer, okay, to provide the interactive graphical interface for searching, finding, and viewing text, document, sound, animation, and other resources on the web. So when we are talking about web browser, of course, I think the most familiar one is Chrome, right? Before this, we have Internet Explorer, but maybe many website is not compatible with the Internet Explorer setting. Okay, we have Mozilla Firefox, Safari, and now one of the best browser for Windows is Microsoft Edge. Okay, so Microsoft is actually a cross-platform web browser. So it is created by Microsoft. Okay. Okay, digital revolution. So mobile multimedia is an agent of change to improve quality of life, health, social. Okay, we use mobile multimedia. So this mobile multimedia can be used in retail. Okay, for example, the push message about store, sales, and it use global positioning system. This one for the location, for example. Okay, and then we can use for education, where the homework assignment completed by students on tablet or mobile device, or even you can use your mobile. Okay, we have mobile multimedia for you to finish or to complete your Photoshop assignment, for example. Okay, we have portable Photoshop. Okay, for example. So it can be done actually through mobile. Travel. So in travel, so we can read text while driving, but of course it will distract you, right? But then you can reading text while driving in a flight Wi-Fi, or we can use our mobile to hail a taxi, for example, Uber, Grab, and so on. Okay. And in terms of games and entertainment and home, so we have new technology of touch screen, okay, streaming music player using Spotify and connect with speaker system, smart home, we have alarm detector. So we use mobile, okay. That is how the revolution, the digital revolution, okay, the digital revolution. So in terms of mobile hardware, becoming small, okay, our handset, our smartphone, okay, desktop, tablet, it becomes small in terms of size, okay. And then smaller hardware, single device can perform more than one task. So for example, your mobile phone or your smartphone, you can have your calculator there, you can have the biometric scanner, okay, everything in one device, in a single device. So we can have biometric, eye tracking, camera, note taker, recorder, calculator, what else? Okay, I think our smartphone now can do all of that task, right? Mm. Okay, now we move to various type of connection. So our device is actually connected by radio, Wi-Fi, or NFC. So however, it needs protocol or handshake to identify and authenticate each other. Okay, we cannot simply like okay, handshake with anybody. No, they need this handshake to communicate. Okay, to introduce between those devices, for example. Okay, so first we have GSM versus CDMA. So both are radio system. Okay, so this CDMA, code division multiple access, versus GSM, global system for mobile communication. So for GSM, okay, I go for GSM first. So GSM use FDMA, okay, the frequency division multiple access, and also TDMA, time division multiple access. Okay, so when they have these what we call that both, okay, when we have both, so meaning that this GSM support both data and voice transmission. Okay, data and voice transmission, but not for CDMA. Okay, so in GSM, the information of the customer is they put into a SIM card. So when we use this SIM card, it can be moved to a new mobile phone and it can be used in other mobile phone. Okay, but for CDMA, the information is only stored on the mobile phone itself. Okay, and this CDMA actually can is used in a certain country. Okay, in a certain country. So like for example, used by Sprint, Verizon, US. Okay, so in Malaysia, of course, we use GSM, right? So they use SIM card. So what is SIM card? SIM card is subscriber identity module. So actually our identity is carried by that SIM card. Okay, our identity is carried by that SIM card. So like now in Malaysia, we have to register our name, we have to register our information on to own a SIM card, right? So 3G versus 4G, and now we have 5G, okay? So this is the radio system. So basically, if they're talking about 3G versus 4G versus 5G, the most, what is the most different one is of course in terms of the speed, okay? 5G is the most fastest one, right? So I think now we only have maybe 4G and 5G, right? So Wi-Fi need wireless access point, WAP, usually combined with network to provide hotspot. Remember, the public hotspot, you need to be careful with, especially when you transfer something or you want to share your your information. Okay. Bluetooth short range, low power radio technology. So if you want to use your Bluetooth, they have the limited what we call that, the from the source and destination from one device to another device, it has limited range. It has a limited range. Okay, short range. So interconnect up to 7 devices per radio. But if you have Apple, for example, you use Apple iPhone, for example, I think you cannot you cannot have the Bluetooth connection with the non-iPhone user, right? If I'm mistaken. Even they do, I am not sure that they have the Bluetooth or not, okay, for iPhone, but it can connect. You can have another connection, the connection with non-iPhone user. Okay, mobile operating system, we have iOS versus Android. So we know that Android is an open source OS for mobile devices based on Linux kernel. Okay, for example, we have Project, Gingerbread, Honeycomb, and so on. Okay, there are so many versions. Okay, so many versions of OS. And then iOS is a proprietary closed OS developed by Apple. So in terms of security, of course, I goes to iOS. Okay, so version 3.1.3, 4.2.1, and so on. Okay, so programming mobile application. So apps for iOS use Objective-C, while Android use Java. Okay, so we know that Android is an open source, okay, OS. So other programmers use hybrid apps, for example, which we have a HTML5, CSS, okay, the structured one, and also JavaScript. And other framework is IDE, Integrated Development Environment, where this IDE is actually enable programmer to consolidate the different aspect of writing a computer program. And most of the developers now actually this is responsive web design. Okay, developing method to deal with many screen size in mobile and desktop, meaning that if you browse a website using your mobile phone or by using your desktop, it can actually fit to your screen size. So they use the responsive web design structure. Okay, so I think that's all for chapter 10, the internet. Don't forget to do some exercises through quizzes. So that's all. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. Bye.